the previous class we have seen the cube roots of unity and nth roots of unity. So today we are going to see the nth roots of a complex number. What are the steps? We can find nth roots of a complex number or find all the values of the complex number. Okay, so you see the first step, write the complex number in polar form. Okay, second one, add 2k pi to the argument, that is argument is theta. Then you have to apply De Morgan's theorem and substitute k is equal to 0, 1, 2, etc. and you have to complete it. Okay, suppose if 3 values now you can start from 0, 1, 2. 4 values means 0, 1, 2, 3 you have to substitute. Starting from 0 you have to substitute the values. Okay, you see the exercise 2.8 fifth question. Solve the equation z cube plus 27 is equal to 0. Just consider this, and z cube is equal to minus 27. So z is equal to minus 27 the whole power 1 by 3. So how it can be written? 27 the whole power 1 by 3 into minus 1 the whole power 1 by 3. So it is a 3 cube. So the cubic root of 27 is equal to 3. Okay, so minus 1 the whole power 1 by 3. How many it has? How many solutions? 3 solutions. Okay, so using De Morgan's theorem and polar form we are going to find the solution. So see that the minus 1, what's the first step? You have to write it in the polar form. So minus 1 node polar form is cos pi plus I sin pi. Okay, see that cos pi is minus 1, sin pi is 0. So the polar form of minus 1 is cos pi plus I sin pi, the whole power 1 by 3. What's the second step I have said? Add 2k pi to the argument, that is theta. So here your theta is pi. So you along with pi you have to add 2k pi. So it is cos 2k pi plus pi plus I sin 2k pi plus pi, the whole power 1 by 3. The next step is you have to apply De Morgan's theorem. So see that using De Morgan's theorem you have to apply the power. So it will become cos of 2k pi plus pi by 3 plus I sin 2k pi plus pi by 3, and you have to substitute the value starting from 0. Okay, so how many values? Here you are having denominator, you are having 3. So you have to find 3 values starting from 0, 1, 2. K has to be substituted 0, 1, 2. Okay, so see now first k is equal to 0. You substitute in this form. Okay, z is equal to 3 into k 0 substitute. When you substitute it will become cos pi by 3 plus I sin pi by 3. So cos pi by 3, cos 6 it is 3 cis pi by 3. Here I didn't find the value. Directly I have written 3 into cis pi by 3. What is cis pi by 3? Cis means cos pi by 3 plus I sin pi by 3. K is equal to 1. When you substitute here 1, 2 pi plus pi. That is what? 3 pi by 3. 3 getting cancelled. You are getting pi. So cos pi plus I sin pi. Okay, so that is equal to 3 into minus 1, that is equal to minus 3. K is equal to 2 when you substitute. Here you are going to substitute 2. So it is 4 pi plus pi. So that is cos 5 pi by 3 plus I sin 5 pi by 3. So cos plus I sin can be written as 3 cis pi by 3. You see the values? 3 cis pi by 3 minus 3 and 3 cis 5 pi by 3. So these are the 3 values of this equation. Okay, wow. So finding nth roots of a complex number or finding all the values of the complex number. So you have to follow the 3 steps. The first step is write the complex number in the polar form. Then add 2k pi to the argument theta. Then you have to apply De Morgan's theorem and substitute k values starting from 0, 1, 2, etc. up to n minus 1. Up to n minus 1. Okay, see that. Next one, 10th problem. Prove that the values of fourth root of minus 1 or plus or minus 1 by root 2 into 1 plus or minus I. Okay, so you are going to find minus 1 to the power 1 by 4. That is the fourth root of minus 1. So how many values it has? 4 values. Those values we are going to find. Okay. So see that. First, what the first step? You have to write it in the polar form. So what is the polar form of minus 1? It is cos pi plus I sin pi. The whole power 1 by 4. 1 by 4. What is the next step? You have to add 2k pi to the argument. So here your argument is pi. So you have to add 2k pi with that. So it will become cos of 2k pi plus I sin 2k pi plus pi. What's the third step? You have to apply the de Moivre's theorem. So while you are applying the de Moivre's theorem, it will become cos of 2k pi plus pi by 4 plus I sin 2k pi plus pi by 4. And you have to substitute the k values starting from 0, 1, 2, 3. I stopped up to 3 because here 4 values starting from 0, 1, 2, 3. You are getting how many values? 4 values. So go for k is equal to 0. While you are substituting k is equal to 0, here this will become 0. So it is cos pi by 4 plus I sin pi by 4. You know very well, pi by 4 is 45 degree. Cos 45 and sin 45 values are 1 by root 2. So here you are having 1 by root 2. This also 1 by root 2 into I is I by root 2. So go for k is equal to 1. So 1, if you are substituting here, it is 2 pi plus pi by 4. That is 3 pi by 4. Okay, so look at this, cos 3 pi by 4 plus I sin 3 pi by 4. You see the rough work? Cos 3 pi by 4. 3 pi by 4 is 135 degree. So how I have written? It is 180 degree minus 45 degree. How it is? It lies in which quadrant? Second quadrant. In the second quadrant, your cos is negative. So I have written negative. Okay. அடுத்தது 180 degree is a even multiple of 90 degree. Isn't it? So you need not change the function. So you have to write cos function as it is. So minus cos pi by 4. Cos pi by 4 is how much? It is 1 by root 2. So cos 3 pi by 4 is nothing but minus 1 by root 2. I have substituted here. The same way sin 3 pi by 4. So look at this, the last one. Sin 3 pi by 4. 3 pi by 4, what I said, it is 135 degree. How you can write? 180 degree minus 45 degree. So 180 degree minus 45 degree, it lies in the second quadrant. Second quadrant, sin is positive. So I have written positive. It is a even multiple of 90 degree. 180 degree is a even multiple of 90 degree. So I write the trigonometry function as it is. So it is sin pi by 4. What is sin pi by 4? It is 1 by root 2. So that's why cos is minus and sin is in plus. Okay, second value I have found. அடுத்தது k is equal to 2. So when you substitute k is equal to 2 here, 2 2s are 4. 4 pi plus 5, that is 5 pi by 4 plus I sin 5 pi by 4. What is 5 pi by 4? It is nothing but what is this? 225 degree. What is it? 225 degree. So how you can write 180 plus 45 degree? So it lies in the third quadrant. In the third quadrant, cos is negative. So I have written minus. So it is cos pi by 4, that is minus 1 by root 2. So here you are having minus 1 by root 2. In the same way, sin also, it 5 pi by 4 is 225 degree. It lies in the third quadrant. Sin also negative. So it will be minus I by root 2. When you substitute k is equal to 3, 3 substitute while you are substituting here, it is 6 pi plus pi. That is 7 pi by 4 plus I sin 7 pi by 4. It is 7 pi by 4 is nothing but 315 degree. Okay, so how I have written? It is 2 pi. 2 pi is what? 360 degree. 360 degree minus 45 degree is equal to 315 degree. Okay, so it lies in which quadrant? Fourth quadrant. In the fourth quadrant, cos is positive, sin is negative. So here cos, so I have written positive. So your answer is 1 by root 2. In the same way, in the fourth quadrant, sin is negative. So minus I by root 2. So therefore, the fourth root of minus 1, whose values are, you see, look at this, all the values plus or minus 1 by root 2 into 1 plus or minus I. How it come in all the values, 1 by root 2 is common. I have taken out. So the remaining is 1 plus I. So here you are having minus. So that's why 1 plus or minus I. Next, Euler's form of the complex number. Okay, so the Euler's formula, cos theta plus I sin theta can be written as e power I theta. That is the Euler's formula of representing the complex number. Okay, you look at this. Z, the complex number, I have denoted Z. Z is equal to x plus iy. That can be written as r into cos theta plus I sin theta. That can be written as r into e power I theta. Okay, so the complex number which it is in rectangular form. The same complex number which is in polar form. And this the same complex number which can be written in Euler's form. Okay, so see that this is the rectangular form of the complex number, this is the polar form, and this is the Euler form. Okay, so e power I theta is nothing but cos theta plus I sin theta, and already I have told in the problem cos theta plus I sin theta can be written as cis theta. Okay, so see the next result. The complex number Z is a complex number. When it is multiplied with e power I theta, what will happen to this complex number is nothing but the rotation of Z in the counterclockwise direction about the origin by theta radians. So the complex number Z, when it is multiplied with e power I theta, we are rotating the complex number in the counterclockwise direction by the angle theta radians. Using this result, we are going to do the problem exercise 2.8, that is the 9th problem. If Z is equal to 2 minus 2i, we are going to find the rotation of Z by theta radians in the counterclockwise direction about the origin. Okay, so see now what are the thetas are given. First subdivision theta is equal to pi by 3, that is 60 degree. Second subdivision theta is equal to 2 pi by 3. In the third subdivision theta is equal to 3 pi by 2. This is the question. For now we are going to see the solution. Okay, so first what we are going to do is take the complex number given. What is the complex number given? Z is equal to 2 minus 2i. So take it and you have to write it in the polar form. Okay, so you know the procedure of the polar form. R into cos theta plus I sin theta. How to find R? R is nothing but the modulus of the complex number. So it's a square root of real part the whole square plus imaginary part the whole square. So here it is root 8, that is equal to 2 root 2. So next step you have to find alpha. Alpha using the formula tan inverse of imaginary part by real part. Here your imaginary part is minus 2. Minus 2 by 2. So that is equal to tan inverse of minus 1. So modulus of minus 1 is nothing but 1. In the place of 1 I have written tan pi by 4. Okay, tan 45 degree. So your answer will become pi by 4. What is your alpha now? It is pi by 4. And the next step what you have to do? You have to check the complex number in which quadrant it lies. So see that the real part is positive and the imaginary part is negative. So the complex number 2 minus 2i lies in the fourth quadrant. If it is in the fourth quadrant, the theta is equal to minus alpha. So I have written alpha is pi by 4. So now your theta is equal to minus alpha. So minus pi by 4. So we can write this complex number 2 minus 2i is equal to, in the place of r, 2 root 2 cos of minus pi by 4 plus I sin minus pi by 4. If what I did, the given complex number I changed into the polar form. Okay, now what you have to find? You have to find the rotation of this complex number by theta. In the first subdivision, what is theta is given? Theta is equal to pi by 3. So I have taken theta is equal to pi by 3. Okay, so what is the answer? When you can get the rotation of Z in the counterclockwise direction about the origin by theta means what you have to do? You have to multiply these two complex number. What is it? Z into e power I theta. So I consider Z into e power I theta. Z e power I, in the place of theta I have substituted pi by 3. Okay, what is Z? Z is nothing but 2 minus 2i. So how you can write e power I pi by 3? I have said the Euler form. E power I theta means what? Cos theta plus I sin theta. Now in the place of theta what you are having? Pi by 3. So it will become e power I pi by 3 Euler form. It will be written as a polar form as cos pi by 3 plus I sin pi by 3. Okay, and 2 minus 2i, which is in rectangular form, it has to be converted in the polar form. So I have found the polar form is here, so I am going to substitute here. 2 minus 2i is nothing but 2 root 2 cos of minus pi by 4 plus I sin of minus pi by 4 into this one. Okay, so see that 2 root 2, here both are in the form of cos theta plus I sin theta. Already we have learned the formula. If they are in multiplication, cos theta plus I sin theta, both the terms are in multiplication. How to multiply? You have to add the angles. So it will become cos of minus pi by 4 plus pi by 3 plus I sin of minus pi by 4 plus pi by 3. So when you take LCM is 12, so it is minus 3 pi by 4 plus 4 pi. So the answer is pi by 12. So when this complex number Z is rotated by pi by 3 radians in the counterclockwise direction about the origin, you will get the new position of the complex number as this. Okay, we'll see the second subdivision. See that here the theta is given 2 pi by 3. Okay, so what you have to do? You have to find Z into e power I theta. In the place of theta, you have to substitute 2 pi by 3. Z is what? 2 minus 2i. Okay, what polar form of 2 minus 2i is this, and e power I 2 pi by 3 can be written as cos 2 pi by 3 plus I sin 2 pi by 3. So you have to multiply. So how to multiply? You have to add the angles. So minus pi by 4 plus 2 pi by 3. If you take LCM is 12. So it is minus 3 pi by 4. Minus 3 pi plus 8 pi. So that is equal to 5 pi by 12. In the third subdivision, the theta is given as 3 pi by 12. So you have to consider Z into e power I theta. The same thing, the theta you have to substitute 3 pi by 2. Okay, Z or polar form is this, and e power I 3 pi by 2 is this, cos 3 pi by 2 plus I sin 3 pi by 2. So when you multiply, what you have to do? You have to add the angles. So minus pi by 4 plus 3 pi by 2. So take LCM is 4. So it is minus 4 plus 6 pi. So the answer is 5 pi by 4. So we are getting the answer 2 root 2 into cos 5 pi by 4 plus I sin 5 pi by 4. Thank you, students.